Hello and good morning to you. We start our lesson of this term by correcting the exercises or the tests that you guys just did. We will be doing the tests, rather we will be doing the correction, and when the correction is done, that is when we will be moving on to new topics. I have to let you know that this is a very short term, and so I will expect you to always attend all the lessons and make sure you understand everything. Make an effort to ask questions, make an effort to reach to me so that before we move on to the next concept, you have understood the previous concept well. So we will begin, as I indicated, with the correction of the test that you did. Then after that, we will move on to a new concept. Now I will be sharing with you on the screen the copy of the question paper, in case you don't have one with you right now. So there we go. Yes. So this is what we have for our lesson of this time. We are going right away to question 1. There we are. So the paper has got 2 sections. The first section is section A, and the second one is section B. We will start with section A, and section A starts with question 1. All right, so for question 1, the instruction is that we answer this question on the answer sheet provided. For the sake of the correction, we will be answering it on another program, MS Office. And the instruction for this specific question on how to do it is that we put ticks, okay? We have got to put ticks in the relevant boxes. So for example, if we have seen that 4 pi divided by pi is a natural number, then we have got to tick. We put a tick in this box. If we notice that 4 pi divided by pi is an integer, we put a tick inside this box. Or if 4 pi divided by pi is a real number, then we put a tick in this box. Just like that, until we reach the what? Until we reach the last box. If we notice that 4 pi divided by pi is, for example, not an integer, then we leave the box open. So it's about putting a tick inside the box or not putting a tick inside the box. So the tick that we put will be the description of whether this number is a natural number or an integer or it's a real number. Okay. So yes, the concept of number is appearing again here. And well, how else do we use numbers in our everyday life? Apart from this 4 pi thing, you know, the cube root of -8, you know, 7 divided by 3, or this type of thing. How else do we use numbers in our everyday life? Well, we use numbers in a number of ways. The first being PIN, which is the personal identification number. The personal identification number gives you access to some very specific type of material or device. For example, like if you want to unlock your phone, you may have to put in what? Your PIN number. If you want to withdraw some money, say using ATM, you will have to put the PIN number so that you can have access to the amount of money for that bank account. Or in case you would like to enter a house, you may require to put a PIN number before the gate can open. You know, that's also a possibility. Or if you would like to have access, like for example, to a mobile app. If you would like to have access to a mobile app, say WhatsApp or Facebook or something to log in, you may have to put in a PIN number. The PIN number that you put can either be natural numbers or it can be what? Real numbers. Natural numbers are the numbers we use for counting. Then whole numbers are actually natural numbers, but with 0 included. Natural numbers do not include 0. You know, we count as 1, 2, 3, 4 like that. But whole numbers starts from 0. Then the next is what we call integers, which is, you know, a combination of whole numbers plus some negative numbers. Then also rational numbers, which is what? Which is a number expressed as a quotient, like 1 divided by the other, or two numbers with one being numerator, the other one being a denominator. And also we have what? A rational number and real numbers, which is everything inside here. So the combination of rational numbers and irrational numbers, or all these numbers here, they are called real numbers. So yes, PIN number is one way in which we can use the concept of what? The concept of numbers. How else? Well, we also talk about numbers when we are describing or when we are giving our addresses, like house numbers. So house numbers are very specific numbers that identifies one house from the other. So for example, you notice maybe your house number is what? Is 234. Or maybe your house number is 105. Or maybe your house number is, you know, like 10. So house numbers are majorly natural numbers, the counting numbers, you know, because houses are also counted. This is house number 1, this is house number 2, this is house number 3, in that order. So house numbers are part of natural numbers, okay? Then, well, sometimes you could have house numbers being labeled as a whole number, like house number 01, house number 02, or, you know, like something like that. The other number that we also face every day is number plate. These are very specific numbers attached to either cars or like motorcycles, or, you know, these heavy trucks. These numbers specifically identify one car from the other. So for example, if there is an incident, there is an accident, a car is being sold or something like that, you know, these very specific number plates, they help in the process of investigation. So for example, you find the number being RMZ 118 GP, you see? So this one is a combination of some natural numbers plus some letters, okay? So these ones are called house numbers. Rather, these ones are called number plates. And the other numbers you don't want to miss is these numbers on the lift. You know, suppose that you're on a lift and you're moving on to one floor to the other, okay? Then that means you have to place a number. So the number can be like 15, the number can be 10, the number can be, you know, 14, or when it is G, it's like the basement or the ground floor. Sometimes it's written as -1, you know. So you see that as a combination of sometimes whole numbers, sometimes natural numbers, sometimes letters like that. So yes, it's important that we get a proper understanding of numbers and how we can use numbers, okay? So I'm going to, let's see if we can find a tick to put there. So just before we get started, see if we can find a tick. Or not here, just a minute. I've got to get it from this point. So yes, there is one tick here that I guess we have to transfer it. Okay, so there we go. This is what we have. All right, so now 4 pi divided by pi. Here is the question, yes, but it's going to be easy for us to put ticks from here because the other one is in PDF, so it's going to be difficult for us to keep editing. from PDF. We could do it, but that will be for next time. Now, is 4 pi divided by pi a natural number? Well, 4 pi divided by pi can be simplified, okay? Because this pi being the numerator will divide the other pi as the denominator, and we can simply get 4. And so can we use 4 for counting? Can we say I've got 4 pairs of shoes? Can you say we have got 4 sweets? Can you say I've got 4 of this or 4 of that? Yes, we can. And because of that, we can put a tick right in here. So let's have our tick right there. Yes. So this is the tick that we have put there. How about an integer? What did we say about an integer? Well, we said natural numbers and whole numbers are also integers. And since we have already seen 4 as a natural number, that means 4 is also an integer. So what do we do then? Well, we just put a tick again. So we have got to put a tick right here, like that. Then the next thing we also want to include is the concept of real numbers. Well, is 4 a real number? Well, 4 is also a real number because real numbers include everything that we have here. Natural numbers, once a number is a natural number, it's a real number. Once a number is a whole number, is what? It's a real number. Once a number is an integer, it's what? It's a real number. You know, like for all of this. And so we also say 4 is a real number. Then rational number. Can we write 4 as, 4 divided by something? Can we write 4 as 4 divided by 1? Yes, we can write 4 as 4 divided by 1, and so 4 can be written as a rational number. Then how about irrational? Is 4 an irrational number? Well, can we say 4 is an irrational number? No, we cannot say that because the exact opposite of rational number is irrational number. So if 4 is already a rational number, 4 cannot be a rational number, okay? And so is 4 undefined? No, 4 is defined. 4 falls under what? Natural, integer, real, and rational. So 4 has a very good definition. So we move on to what? We move on to the second question, which is the cube root of -8. Well, how can we simplify this? Well, the cube root of -8 is the same as -2. When we simplify it, what do we get? We get -2. So how are we going to describe -2? How are we going to describe this number, -2? Well, yes, we can describe -2, but can we describe it as being a natural number? No, natural number is a counting number. Counting numbers don't have what? Don't have negatives in them. And because we don't have negatives in natural numbers, we say -2 is not a counting number, is not a natural number. How about a whole number? No, whole numbers don't have negatives. How about integers? Yes, integers do have what? Do have negatives. And so we can say -2 is what? Is an integer. That is where we go. So -2 is an integer. Then the next thing is real. Well, is -2 a real number? Yes, -2 is also a real number. Why do we say that? Because everything else here is a real number, okay? Numbers that are used for continuous values. Then the next thing we want to include is what? Rational. Can we write 2 or rather -2 as -2 divided by something? Yes, like -2 divided by 1. And so -2 is what? -2 is a rational number. And it's been defined clearly, it's not an irrational number. Then we move on to 7 divided by 3. Is 7 divided by 3 a natural number? Can we use 7 divided by 3 for counting? No, we only use whole numbers, or we only use numbers that do not have fractions as numbers for counting. And so 7 divided by 3 is not a natural number. How about being an integer? Is 7 divided by 3 an integer? No, it's not an integer. Integers don't have what? Integers don't have fractions. They don't have points like 3 point something, 2 point something, 7 point something, 10 point something. No, they don't have it. Rather, they don't have those ones, or 10 comma something, they don't have it. Well, that means we can move on to real. Is 7 divided by 3 a real number? Yes, it's a real number, because 7 divided by 3 will possibly fall under what? Will possibly fall under one of these rational numbers. And rational numbers are also real numbers. Yes. Then there we go. This is a rational number. It can be expressed as a number divided by the other. And we move on to what? We move on to this next. So this is -5 divided by 2 times 0, which can be written as -5 divided by what? -5 divided by 0, because 2 times 0 is 0. So what is -5 divided by 0? Is it 0? No, -5 divided by 0 is undefined. Let's check right away in a calculator, and you can see what the calculator is going to put. The calculator will put for us an error or something close to that. So now what have we simplified? We have now got that this can be written as -5 divided by 0. Okay, -5 divided by 0. So we want to see what will the calculator say when we divide -5 by 0. What is the calculator going to give us as their response? So let's get that right away. Okay, so -5 divided by 0, right here. -5. Okay, -5 divided by 0. What do we get? Yes, cannot divide by 0. What that means is this is simply undefined. So all the way up to here. Yes. Then the next thing is this last, possibly the last question for question 1, the last part of question 1. We have this, the square root of 1 divided by 2 raised to power -3. How do you simplify this? Well, this one can be simplified as 1 divided by negative, or first do it like this. We will first write it as the square root of, just make it a little bit easier for us to see. So we can write this as the square root of 2 raised to power 3, which is 8. Just put 8 like that, yes. This can be simplified into this value here. Just reduce the size a little bit so that it fits on one line. Yes, like this. So now 1 divided by 2 raised to power -3 is the same as 8. And the square root of 8. Do we have the square root of 8? Let's check. Let's see what we can get. So we want to find the square root of 8. Yes, the square root of 8. You see? The square root of 8 seems to be having this list of numbers that does not stop. Look, it's just that the space is taken up, otherwise it would continue going there. So how do we describe numbers that do not have, perfect squares? How do we describe numbers like 8 that do not have square roots? Because 8 is not a perfect square, since we cannot square any two numbers to get 8. Rather, we cannot square any given number to get 8. So how do we describe this? Is this going to be a natural number? No, natural numbers are used for counting. Is this going to be an integer? No. Do we call it real? Well, surprisingly, it's going to be a real number. As you have seen here, everything inside here is a real number. So possibly the square root of -8 is going to fall under one of these. And also that is why we will call it a real number. So yes, it's a real number. Then is it a rational number? Unfortunately, no, because we cannot express the square root of 8 as one value divided by the other. Then now the next thing is irrational number. Is the square root of 8 an irrational number? Surprisingly, yes. Is the square root of 8 undefined? No, the square root of 8 is defined as either a rational number or a real number. So yes, this is how you would provide the solution to question 1. And this is where we stop. Question 2 will be appearing in the what? In the next what? In the next video. Until next time,